for our width, we know that x would have to be greater than 0, right? For our length, we know that this entire length has to be greater than 0. So that means I'm going to go ahead and make that greater than 0. And if I solve for x here and add 3 to each side, I'm going to get 2x is greater than 3. X would have to be greater than 3/2. Now, we have two answers. So my question is, can x be 0 or 3/2? Or does it have to be, x has to be greater than just 3/2? This is an and problem. It has to be greater than 0, and it also has to be greater than 3/2, because, which is the same as 1.5. Because if I put 1 in here, it may work for my width, but it definitely will not work for my length, because I'll still be negative. So that means our domain has to be greater than 3/2. So we're going to write that our domain is a set of all x values such that x has to be greater than 3/2. So that's our domain for this particular function. So in the implied domain, it has to make sense within the context of our problem. Next, what are the independent and dependent variables? Well, our dependent variable is our y values, which are our outputs. Our independent variable, something we probably need to cover more of, is our x values, or our inputs. So with respect to this function here, it was p of x equals, and again, I'm just going to rewrite this simplified, 6x minus 6. Well, my inputs are my x values, and so that's why I'm going to write my independent variables are my x values. My dependent variable, we only have one, so it should be variable, not variables. Okay? Is our y value. But remember, in function notation, p of x is equivalent to y. So that means p of x is our dependent variable. All right? Where our independent is just our x, our input. All right. Part C, what is the perimeter of a rectangle whose width is 12 feet? Well, I'm going to go back to that other side here. So if you go ahead and rewrite this function, which was p of x equals 2x plus 2 times the quantity 2x plus minus 3, all they're asking you to do is substitute in 12 in place of x, because x represents the width. So to do that, you could do this one of two ways. You could literally substitute in 12 wherever you see an x. All right, and all I'm going to do is substitute in 12 in here. You know, you could perform the order of operations and do that. The other thing you could have done, I'm just going to really quickly draw a little line here, showing you that if you recall on the other page, I did simplify this function. I did simplify it to p of x equals 6x minus 6. So you could also take a look at it from this point of view. We actually can go ahead and substitute in 12 wherever there is an x. So it is totally up to you. I just think personally this one is a lot simpler because it's already evaluated and we just need to simplify. So 72 minus 6 is 66. And this is feet. So, you know, in a sentence you write the perimeter of the rectangle is 66 feet that has a width of 12 feet. The other thing, if you want to evaluate this and simplify it, you're going to get 24 plus, you do what's in the innermost parentheses first. So 2 times 24 minus 3 is 21. So 2 times 21 is 42. And 42 plus 24 is 66. So either way you do this, you're still going to get 66 feet. All right, what is the width of the rectangle whose perimeter is 84 feet? Again, you could simplify this original function. And I think that's actually where I'm going to go from here. I'm going to keep it simplified. Now they're telling us that the perimeter is 84 feet. And remember, the perimeter is this entire P of x. So all I'm going to do is substitute in 84 wherever P of x is. And then from there, all I'm going to do is solve for x, which is my width, because that's my unknown, and that's what we're looking for. What is the width? So I'm going to add 6 to both sides, isolate that variable. I'm going to drag this over, get it out of our way. 6x equals 90. Divide by 6, and x equals 15, and it's feet again. So in a full sentence, you'd say the width of the rectangle is 15 feet, whose perimeter is 84 feet. And that's it for our 3.1 notes. I know that we're going to be covering problem 24 and 48 in class. Otherwise, that's it.